My name is Purshotam, along with my co-speaker Prakash. And with my co-speaker Prakash, we'll be talking about how to run cost-effective and secure batch jobs on Flink using Airflow. I work on low latency team at Yahoo. I'm also a PMC member of Uzi and Storm. So let's start with the agenda. We'll talk about the challenge that we had. Then I'll cover Flink overview. Then we'll talk about some of the security requirements that we had. Then Prakash will take over and he will talk about problem use case. Then he'll talk about the Airflow integration. And the next he will talk about the high-level architecture, then end-to-end flow, then security challenges and cost optimization. So when we were looking like what application to pick for the ads team for the batch processing, we identified 4 key areas that has to be delivered on. So one was a reduced learning curve. The ads team were already using Flink for their stream processing, and we wonder, can we use Flink for batch too? And second was the operational overhead. The ops team, operational team, had script and everything set up for monitoring their Flink jobs, which include having Grafana dashboard monitoring and alerting. So we thought if we can use Flink for batch, that will reduce their work. The third one was the cost. And Prakash will talk more about this, like how do we reduce the cost with Flink for batch. And the security. And we're going to talk in detail about this in coming slides. I also want to mention that there are people at Yahoo who use Hive Spark for batch processing. This is only for the ads team where they wanted to use Flink for batch processing. And we do support Flink for batch processing too. Now, besides just their requirement, there are other benefits of using Flink for batch processing. The first is unified processing engine. So Flink has a simple API that can be used for both batch and streaming. The second is that Flink has a support of auto scaling and auto tuning. The auto scaling, it can scale up the nodes that's needed, and auto tuning is very cool. So we run on FlinkKubernetesOperator, and the operator can monitor the job for the memory users. If it's need more memory, then kill the pod and restart with more memory requirement. If it's underutilizing, it can kill and reduce the memory requirement. Third, as I said, that we are using FlinkKubernetesOperator, so it simplifies a job cycle management. It also helps with the rollback and rolling upgrade, etc. The third one is isolation. Now, with the help of EKS and since it has a feature of auto scaling, auto tuning, we can really run job in isolation, where we run one job per Flink cluster. This has a lot of advantages, and one we'll talk in terms of security. And finally, the Flink has a native support for S3 integration. Most of the ads requirement were read from S3 and write to S3. So Flink has support, and it doesn't have to rely on any Hadoop libraries. Now, the solution was to use Flink and Flink and on EKS, FlinkKubernetesOperator, and these are both open source. Now, let's move to something which is very critical to our talk, which is security. Now, our goal was to run Flink on secure environment. And Paranoid, the Yahoo security team, has a lot of requirements for that. The one, they wanted to make sure that all of the communication, whether internal or external from Flink, has to be mTLS. They also wanted to make sure that the UI access is protected by Okta. They also wanted to make sure that the secret management, all of the secrets that used by the Flink cluster, including the key store and trust store password, has to go in the secret management service. Let's talk about the external communication. And before I look into that, I want to talk about Athenz. Now, Athenz is an open source platform that used for XO59 certificate-based service for authorization or authentication. Now, one of the cool things that we can do with the Athenz is that you can customize a CNAME. Now, CNAME, in our case, is made of 2 things. One is a domain, and one is a service or role. Now, think domain as a term of team. So one team can have one domain. So, and services like the service they use. So when we configure Flink on EKS, each pod can be configured to fetch a specific certificate from Athenz service. And it can be Athenz domain and service. Now, since we talked about isolation where we run one Flink cluster per job, what Paranoid wanted us to do is that each cluster should be accessed by the team who owns it, not everybody at Yahoo. And this is done using the CNAME check. And this is something we added on top of the open source. So there are 2 kinds of security happens here. One is the mTLS that is available by open source, and And on top of that, we do the CNAME check. So when the request comes to the Flink cluster, the first mTLS and the CNAME. If you look at the example here, it says finance.star, which means that anybody at the finance team can access the cluster. And same goes for the internal communication. Within the Flink cluster, when the job manager talks to the task manager or task manager talks to task manager, they should be very strict. And in this case, if you look at the example that says finance.app1, the CNAME check, which means that any node that has a certificate for finance.app1, they can only take part in communication, nobody else. The next one is how do we protect the Okta, how do we protect the UI? As again, the paranoid wanted us to protect the UI using the Okta token. And this is done by adding a sidecar to the Flink deployment. The advantage of adding sidecar is that we don't have to make any code changes to support Okta authentication. So what we do is at step 1, we add a sidecar to the Flink deployment, and then we expose a new service. Then all the requests goes by that service. And when user try to access a Flink cluster using UI, the sidecar checks whether he has a valid token or not. If he has a valid token, the request is redirected to job manager. If it doesn't have a valid token, then the access is denied. And if it doesn't have any token, we redirect the request to the Okta page where they can ask for authentication. Now, in this case also, for Okta app, you can have one Okta app per Flink cluster. So, and you can say who can access those particular Okta app. I also want to say that the Flink cluster, there are only 2 ways to access it. One is using Athenz mTLS and other is Okta. There is no other way of accessing the Flink cluster. And that was one of the challenges. And Prakash will talk more about like how do we make it work with AWS managed Airflow. This is overall deployment architecture only for the Flink, not for the Airflow. And if you look at, you can submit jobs from Jenkins or users. And so there are multiple steps. You can have to submit FlinkKubernetesOperator first, and then the Flink cluster. I'm not going to go in detail to that. Just wanted to focus on the job manager part. You see there is a sidecar, Athenz sidecar, which is responsible for fetching the Athenz certificate from Athenz service, and also refresh it as it expires, and the Okta sidecar that we already talked about.
I am Prakash. I am from Yahoo Ads data platform team. In this slide, we will see the challenges that we had faced. At Yahoo, we process a massive amount of conversion data from different partners. Think of millions of records every hour. We needed a solution that could handle enterprise constraints, such as mutual TLS for security and IAM control for accessing AWS resources and full auditability. While many tools exist individually, making them work together at enterprise scale with the Yahoo security requirement was a real challenge. Next, our existing data processing stack was based on Oozie EMR Pig. Oozie was used for scheduling jobs. EMR cluster was running the Pig data pipelines. The existing solution started struggling to keep up with our evolving needs around security and performance. So the Oozie workflow were XML based, making them difficult to write or manage and test. So this had led us to an unreliable and error-prone data pipelines. Next is the persistent EMR cluster. It had resulted in significant cost from idle compute resources that weren't efficiently utilized. And the third one was retrofitting modern security standards like mTLS and IAM in our existing tech stack was complex and it was unreliable. And this had led a gap in our security and compliance posture. So how did Airflow help us? So Apache Airflow provides robust scheduling, dependency management, and comprehensive monitoring capabilities for our data pipelines. The FlinkKubernetesOperator, it's a custom Airflow operator that seamlessly integrates with Kubernetes, allowing us to declaratively manage our Flink jobs through Kubernetes custom resource definitions. By leveraging both the Airflow and Flink Kubernetes operator, we have been able to completely automate the entire lifecycle of Flink data pipeline, starting from cluster provisioning to data processing to monitoring health and cleaning up the cluster once the data processing is done. This has transformed our processes from manual and error-prone to fully automated and stable with enterprise grade reliability and monitoring. The end result is a significant reduction in manual overhead. Now let's break down the 4 critical requirements that drove our architectural design. First, isolated compute per job. We needed each data processing unit to have its own dedicated cluster so that a dedicated cluster that could exist only for the job's duration. So this helped us in having no noisy neighbors, no source contention, and zero idle cost. The second, strict access control using AWS IAM and Yahoo's Athenz for mTLS. This wasn't optional, it was a requirement by our security team. We needed IAM for AWS resource access and Athenz mTLS for internal communications. Third, zero hard-coded credentials. Everything needs to have short-lived tokens, service identities. And fourth, first-class observability, structured logging and metrics that our operation teams could rely on. When there is a problem, our operation teams needs to resolve the issue immediately rather than looking at different logs and different systems. Now let me walk you through end-to-end execution flow. This diagram shows how all the pieces that we had looked comes into practice, starting from DAG trigger to the final cleanup phase. The flow starts with our Harley DAG trigger. The first thing that we do is wait for the input data. Once the input data is available, we clean the output path to ensure that we are starting afresh. Then we update the EKS kubeconfig. This is critical. We are not using any static kubeconfig and we are using a dynamically generated one. Next, we copy the Flink deployment YAML and OTel configuration from S3. The Flink deployment spec contains all the job parameters, resource requirements, and security configurations templated with Airflow variables. We then apply OTel config map to Kubernetes. This creates observability configuration that our Flink pod will use for metrics and logging. Now comes the core execution phase. The MWAA submits the Flink job to our EKS cluster using FlinkKubernetesOperator. This is where the magic happens. The FlinkKubernetesOperator sees the CR and immediately starts provisioning the resource. The job manager and task manager starts up. These are ephemeral pods that exist only for this job. Each pod has 3 main containers. So the first one is the Flink container, the next one is the Athenz for mTLS, and the third one is the OTel sidecar for observability. The actual data processing is done by the task manager, and the process data is returned back to S3. While the job runs, our MWAA custom sensor polls the Flink deployment CR every 60 seconds. The sensor handles the 3 states. The running means we keep polling. Failed triggers the retry logic with exponential backoff. And finished means success. Whether the job succeeds or fails, we always execute our cleanup phase. This is absolutely critical for our cost control. We delete both the Flink deployment CR and the OTel config map. When we delete the Flink deployment, the Flink operator automatically terminates the task manager and job manager pods. So the key highlight of this flow are no long-lived infrastructure, security is baked in, observability is first class, failure handling is comprehensive, and cost optimization is automatic. The security model of our EKS cluster poses some key challenges. Our EKS cluster only supports Athenz mTLS authentication, not IAM, requiring a custom certificate management for secure communication. MWAA, being an AWS managed service, didn't have native integration to the Athenz, so making it difficult to fetch and refresh Athenz certificate automatically. To bridge the gap, we had to implement an IAM bridge solution where MWAA to EKS communication uses IAM, while the internal Flink communication uses Athenz. For Flink, for the monitoring the Flink jobs, right, it requires Athenz certificate, but we were leveraging EKS IAM protection and using MWAA to monitor the status through Flink deployment custom resource definition. This hybrid approach allows us to maintain a secure and Yahoo compliance system while integrating with the AWS managed service. So this slide highlights key cost control strategies we employ to achieve efficiency. Immediate cleanup of Flux cluster and Kubernetes operator ensures we don't incur ongoing costs for resources after a job completes. Per job isolation gives us a dedicated cluster, optimized resource allocation, and preventing contention between different jobs. Full automation of the resource lifecycle eliminates manual intervention, reduction of operational overheads, and ensuring consistent practice. Together, these three approaches help us maximize cost saving and operational efficiency. So, the production health monitoring is critical for ensuring reliable data pipeline. Our data pipeline are only as reliable as orchestration that runs them. Failed data pipelines can lead to missed SLAs and data gaps for our customers. Proactive monitoring helps us get ahead of issues before they become big problem. The production engineering DAG is our watchdog. It continuously checks the health of all our application DAG. It runs every 5 minutes, querying for failed status across DAGs. It publishes key metrics like failed DAG counts to CloudWatch so we can monitor trends. When issues are detected, it triggers an alert to Chronosphere to notify our on-call team for immediate support. So some of the key takeaways are Airflow, EKS, and FlinkKubernetesOperator provides a strong pattern for secure batch processing. The setup that we use is simple. It provides a simple deployment process. It allows for simplified removal of idle Flux clusters. Per job cluster reduces cost and improves isolation. It is essential to integrate security into the orchestration from the start rather than as an afterthought. And finally, observability and cleanup are critical and should not be overlooked.